Hello everyone, my name is Manish and I'm a senior data scientist at Royal Cyber. In this video, we will learn about the Mixtral 8x7B model that were released recently. We will briefly see how it works and how you can try it out on your own. So let's just get started. Mixtral models have been making a lot of noise over the last few weeks. In some benchmarks, they even beat the GPT 3.5 and the Llama 70 billion parameter model. In the image on the screen, you can see that the Mixtral medium is in at the fifth place, beating Cloud8, Llama, and even GPT 3.5 models. On the other hand, Mixtral 8x7B is in eighth place, just above GPT 3.5. Now, these Mixtral models were developed by a French startup called Mistral AI. They even released the model under Apache 2.0 license, which means you are free to use them for both your commercial or non-commercial purposes without requiring any license or permission. So what does 8x7B mean? How did a 7 billion parameter beat GPT 3.5 model? Let's find out. Mixed models are based on a technique called mixture of experts or MOE. As the name suggests, these are mixture of models that are experts on different tasks. So instead of training one big model, we train multiple small models, each learning some tasks and getting good at them. As you see in this picture, we have five expert blocks. When a new input comes in, the router block selects one or more of the experts suitable for the input. And output from this selected expert is combined either by adding or by some other cumulative operation to form the final output. The selection of this expert is up to the user as to how or how many experts are to be selected at a time. MOE may seem like a new concept, but actually they have been around for a long time. It was first introduced in the paper Adaptive Mixture of Local Experts in 1991, as you see on the left side. You might notice a familiar name among the author list, Geoffrey Hinton. Another paper in 2014 from Google also explored this further. There are actually even rumors that the GPT-4 model is based on the MOE architecture itself. Moving on, you might be wondering if you're training multiple small models, wouldn't they end up being the same as one large model requiring the same compute power? Let's find out. Now let's talk about the Maxwell 8x7B. In this model, there are eight experts, each of 7 billion parameters. The name here is a bit misleading. We would expect 8 times 7 to be 56 billion parameters, but actually there are only about 47 billion. This is because some of the attention layers are shared between the experts, which reduces the number of parameters. So here, as we talked earlier, the router block, it selects two experts depending on the token, and output of these experts is cumulatively added to form the final output. As explained by the authors in the paper, for every token, the router network selects two experts to process the current state and combine their output. So each token has access to 47 billion parameters, although it will use only 13 billion of them during inference. This answers our previous question that even though there are as many parameters as a large LLM, it uses only as many parameters as a small LLM during inference. This also means that the inference speed would be much faster compared to a large LLM, but with comparable quality of responses. Now, how to try it yourself? Trying out this model on your own can be a little bit tricky because even though it's considered a small model and uses only 13 of the 47 billion parameters, you still need a large virtual memory to load the model. This might not be possible to acquire for most people. Fortunately, there are many online resources available where you can try it out for free. I've listed down some of them on the screen. Please and do try them out and let us know how you perform. This wraps up our video. Thank you for watching and have a nice day.